So this worksheet is two parts. The first part, I'm going to briefly review the different methods for solving quadratic equations. And then the second part, I'll do another video reviewing how to come up with the solution set for quadratic inequalities. Okay, so when we're solving a quadratic equation, remember we're coming up with the values and we'll solve over the complex numbers. So all of the complex numbers that when you substitute the complex number in for the variable, you would get a true statement, meaning the left-hand side of the equation would equal to the right-hand side of the equation. So long ago, remember in Algebra 1, you learned these different methods for solving quadratic equations. And some of the methods you may have found to be more efficient or faster than others, but they maybe didn't always work for every single quadratic equation. And then some methods you might have found took longer, however, they were foolproof. They worked every single time for every single quadratic equation. So we're going to go through those different methods, and we're going to start with factoring, the factoring method for solving a quadratic equation. And factoring, you'll see in chapter 2, once we get there, will also be used for solving higher degree polynomial equations as well. So if you remember the zero product property, the zero product property is really important. It says that if you have a product equal to 0, so let's say if we had A times B equals to 0, that means that at least one of the factors must be equal to 0 to make that a true statement. So that means that either A is equal to 0 or B is equal to 0. And the way that we can use that for solving a quadratic equation is if we were to rewrite our quadratic expression. So if we get a quadratic in the form ax squared plus bx plus c on one side of the equation and 0 on the other, and we rewrite ax squared plus bx plus c in factored form, meaning we're rewriting it as a product, then we can apply the zero product property in order to find the solutions or those values that would give us a true statement. So like looking at this equation that I have here, that's the quantity x minus 2 times the quantity x plus 7 equals to 0. Well, if we thought of x minus 2 as being one factor, so in what I wrote above as being like A, and then x plus 7 as being the second factor, B, we can look at these factors and determine just by looking or inspecting what values would make each of those factors equal to 0. So for x minus 2, if x were equal to 2, that would make that factor 0, meaning the left-hand side would end up simplifying to be 0. And then if we look at the second factor, we can see if x were equal to negative 7, that would make that second factor equal to 0, and therefore the left-hand side of the equation 0. So whenever I talk about solving inspection, you'll hear me referencing solving by inspection often. It's just if I'm looking at the equation, what values would make this a true statement? So I didn't use any algebra or need to use any algebra. Okay, now the thing about factoring, it's not foolproof. It does not work for every single quadratic equation. It's really efficient and it can be fast, but if it's not, you might want to use other methods for solving a quadratic equation, which we'll talk about. Okay, so let's look at this equation we have here, x squared minus 6x minus 16 equals to 0. And let's try and solve this equation by factoring, meaning we're going to try and rewrite the left-hand side here as a product. Super important to make sure you get 0 on one side of the equation first, so that then once you rewrite the other side of the equation as a product, you can think about applying that 0 product property. Okay, for factoring, it's all of the different methods. Your teacher in Algebra 1 may have given, or pre-algebra, or wherever you learned factoring, quadratics, might have given you some sort of a strategy to factor, but really it's all guess and check. So I'm going to think, okay, well, x times x, if I were to multiply this out, x times x would give me that x squared. Now I need to think about two numbers that when multiplied together would give me negative 16. So what first comes to mind for me would be like either 2 and negative 8 and negative 8 and positive 2. Well, I need those numbers to add or sum to negative 6. So I'm going to use positive 2, negative 8. And if I think about multiplying that out, right, that would be x times x is x squared, then minus 8x plus 2x minus 16. And the negative 8x plus 2x would give me that negative 6x. So that is factored correctly. And then now by inspection, I can see that x can be equal to negative 2 or x could be equal to positive 8. So negative 2 and 8 are the solutions to this quadratic equation. Okay, just a warning to be careful whenever you're solving an equation that maybe only has two of the terms. Like there's no constant in this quadratic equation. So a common mistake that I see is going, oh, well, I can divide by x on both sides. But if you do that, you're going to lose a solution. So you need to, when you're solving a quadratic, or anything that's higher than a degree of 1, any polynomial equation that's a higher degree than 1, and we'll talk about that more in chapter 2, you need to factor. So I noticed that there's an x in each of these terms, so I can actually factor out an x, and then now by 0 product property, I can see that x could be equal to 0 to make that a true statement, or x could be equal to positive 4 to make that a true statement. So 0 and 4 would be the solutions to this equation. And if you tried dividing by x, never divide by an unknown. So if you divided by x on each side of the equation here, then you'd only be left with x minus 4 equals to 0, and you would have lost your solution of 0. So never divide by the variable. Okay, and then let's do this one. So we're going to factor. This one's a little bit different just because the leading coefficient is not 1, it's 3. So I'm thinking, okay, well, how can I factor the 3x squared? Well, since 3 is prime, I know I'll have a 3x and an x. It can be a little bit more complicated if that leading coefficient is not prime. All right, and then I'm thinking, okay, two numbers that would multiply together to give me negative 8, maybe 4 and negative 2, or 2 and negative 4. Well, since I need to get a sum of 10x, I'm going to do plus 4 there, so that 3x times 4 would give me 12x, and then I'm going to do minus 2, so that then we can subtract 2x to give us the 10x. Okay, and then either by inspection, or if you feel like you need to do the step of writing out 3x minus 2 equals to 0, and then using properties of equality to finish solving for x, where you get 2/3, you can do that. But positive 2/3 and negative 4 are our solutions to this equation. Okay, so super important to remember to get 0 on one side of the equation before you factor. And that's, again, so that you can apply the zero product property for coming up with the solution. All right, some equations, also not foolproof, it's just whenever you can use it, you can use the square root property, which says that if we have x squared equal to a constant c, then x can be equal to plus or minus the square root of c. So basically, if you don't have the middle term, so we think of a quadratic in standard form as being ax squared plus bx plus c equals to 0. So if b is equal to 0, meaning there's no middle term, then you can use the square root property. So here, this could also be factored, right? That's a difference of 2 squares, and you could easily factor that quickly. Or if your brain goes directly to using square root property, that's totally fine too. So you can rewrite this as x squared equals to 16 after adding 16 to both sides of the equation. And then x would be equal to plus or minus the square root of 16, which you know is plus or minus 4. And that plus or minus represents two different values, right? So that's x is equal to negative 4 or x is equal to positive 4. So 4 and negative 4 are the solutions to that equation. Okay, and then let's do this one. We need to isolate the x squared. So we're going to add 27. I'll do this in multiple steps. You might not need to. I'm going to add 27 to both sides of the equation. It's an addition property of equality. And then I'm going to divide by 3 on each side of the equation. So I get x squared equals to 9. So x equals to plus or minus the square root of 9, which you all know is 3. And remember, that separates to be two different solutions. So x equals to negative 3 or x equals to positive 3. And we'll do one more before we move on to completing the square. So isolating the x squared on one side of the equation. Okay, applying that square root property, x would be equal to plus or minus the square root of 8. 8 is not a perfect square, meaning there's not a number when multiplied there's not a whole number that when multiplied by itself would give us 8. But we can simplify the square root of 8, right? 8 can be rewritten as 4 times 2. And 4 is a perfect square. So this actually simplifies. I'm going to write this in a new line. The square root of 8 actually will simplify to be plus or minus 2 root 2. And that's x equals to negative 2 root 2 or x equals to positive 2 root 2. Okay, not as popular as the fourth method that I'm going to talk about, but it is the basis for the fourth method, or it's how you can derive the fourth method, which is the quadratic formula. But you can solve any quadratic equation by completing the square, which is great. It's foolproof. So if you like to complete the square, go for it. It'll work. It's just not always the most efficient. Sometimes if you have a leading coefficient, you'll end up with fractions that it can just make it a little bit more complicated, but you can definitely solve by completing the square. So when you complete the square, you're rewriting an equation that's in standard form. Remember, standard form is this ax squared plus bx plus c equals to 0 into this form. A times the quantity x minus h squared plus k equals to 0. And from studying quadratics before, you guys have studied quadratic equations, you've studied quadratic functions. Remember that you can rewrite the equation that represents a quadratic function in vertex form by completing the square. So it's, remember where h, comma k would represent the vertex, and we'll talk more about that in chapter 2. But we'll go through, so by completing the square, you can also rewrite in what we call vertex form. And yeah, we'll talk about that more in chapter 2. But from that form, you can then isolate the square and use the square root property to finish solving for x. Now, it's super important to remember, and it's a common mistake to forget, that if a is equal, so a here, so if a is not equal to 1, you need to make sure that you factor that value out before you complete the square. Okay, so let's go through our steps for completing the square. So notice that a here is equal to 1, so we don't need to factor anything out. I'm going to show you how to complete the square on one side of the equation, just for I think it's good practice to be able to complete the square on one side, just so then whenever we are reviewing quadratic functions, you'll be able to change to vertex form, which will be really handy. So I'm going to go through completing the square on one side of the equation. If you complete the square by adding the same value using the addition property of equality, that may have been how you were taught in Algebra 1, and that's totally fine. Okay, so first thing I'm going to do here is rewrite this, leaving space between the negative 10x and the minus 3. Okay, because what I'm going to do is I'm going to add 0 to the left-hand side here. Because if I add 0 to the left-hand side, it's not going to change the value of the left-hand side. So the equation remains the same, meaning the left-hand side equals to the right-hand side. So what I'm going to do is I'm going to add negative 10 divided by 2 squared and subtract it. Oops, switch back. Let me switch colors here. So I'm going to add negative 10 divided by 2 squared and also subtract. And you don't need to write it out like this. You can do it in your head. They're going to end up adding and subtracting 25. That's totally fine. So let me simplify this. So I'll have x squared minus 10x plus 25 minus 25 minus 3 equals to 0. Okay. Now, by the associative property of addition, I'm going to group these first 3 terms together. I'm going to reassociate them. Okay. This factors to be a perfect square now. This factors, you can think about just factoring it, but it'll actually always factor to be x plus half of this value. So this is going to be x minus 5 squared, and then negative 25 minus 3 will be minus 28. So from here, now I've completed the square, I did the hard part. Now I'm going to isolate the x minus 5 squared by adding 28 to both sides of the equation. I can take the square root or use the square root property here. So x minus 5 is going to be equal to plus or minus the square root of 28. I'm going to simplify square root of 28. 28 can be written as 4 times 7, so 2 root 7. And then I'll add 5 to each side of the equation. Okay, and notice that I'm putting the 5 in front of the plus or minus. You want to do that, put that value in front of the plus or minus. And that represents two different values. So that represents 5 plus 2 root 7 and 5 minus 2 root 7. So both of those values are solutions to this equation, meaning if you were to substitute those values, and they're irrational numbers, right? We have a root 7 in there. Root 7 is an irrational number. But if you substitute those values in for x, the left-hand side would become 0. Oh, let's do one more, completing the square. Now, leading coefficient is not equal to 1. So before we complete this square, we need to factor out the 2. Now, since we're solving an equation here, we're actually allowed to divide by 2 on both sides of the equation here, so that coefficient goes away. However, if we were trying to rewrite y equals to 2x squared minus 6x plus 8 in vertex form, we would need to hold on to that 2 because that 2 represents a vertical stretch. So we couldn't just divide it out. But because this is an equation that we're solving for an unknown, and we have 0 on the other side of the equation, we are allowed to divide by 2 on each side. So we'll have x squared minus 3x. I'm going to leave my space for adding 0. Okay, so now I'm going to add negative 3 divided by 2 squared, which will end up being 9/4, and subtract that value as well. Okay, by the associative property of addition, I'll group those first 3 terms. And then I'm going to actually just go straight to factoring here. So that'll be x minus 3/2 squared. And then negative 9/4 plus 4 would end up being, is that 7/4? Yeah, 7/4. Because that would be negative 9/4 plus 16/4. Okay, so now isolating the x minus 3/2 squared on the left-hand side of the equation. Ooh. Okay, notice that we have negative 7/4 on the right-hand side of the equation. So when we take the square root here, we're going to end up having x minus 3/2 equals to plus or minus the square root of negative 7/4. And you guys know that when you take the square root of a negative number, it actually represents an imaginary number. So let's see, we're going to be able to simplify this a little bit too. So I'm going to add the 3/2 to both sides. And I'm going to rewrite this as plus or minus. That'll be the square root of 7i and then over 4. So I can, instead of having the square root of negative 7 written there, I can rewrite that as the square root of 7i. And remember that, like if you have the square root of a over b, that's equal to root a over root b. That's why I was able to simplify the denominator, which does not actually simplify 4, simplifies to 2, because the square root of 4 is 2. There we go. Okay, so then I'm going to separate those two solutions. That'll be 3 plus root 7i all over 2, because we have a common denominator, or x equals to 3 minus root 7i over 2. So we actually had 2 complex solutions to this quadratic equation. We did not have any real solutions. All right, last method that I'm going to discuss is quadratic formula. And you guys probably all know the song. I'm not going to sing it on here, but I'm sure that you are probably all playing it in your head. Quadratic formula is great. It's another foolproof method for solving any quadratic equation. I think for a lot of you guys, it's your go-to. It should be your go-to. I will also post a program for your calculator that you can program into your calculator and use. You especially want to have it on your calculator if you're taking any of the standardized tests. Okay, so to derive the quadratic formula, you complete the square for the general quadratic equation. And I have all the steps here. You can look through it. If you have any questions, let me know. But we get down to x equals negative b plus or minus the square root b squared of b squared minus 4ac all over 2a. Okay, so for using the quadratic formula, I'm going to identify a, b, and c. 2 is a, 6 is going to be b, negative 5 will be c. Now, when I substitute these values into the quadratic formula, I'm going to use parentheses. This is so I don't have any sign errors. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Please make sure that your division bar extends so that your entire numerator, it's under your entire numerator. And please also make sure that the radical here extends as well. Okay, let's simplify this. That's going to be negative 6 plus or minus the square root of 76 over 4. Let's see, does square root of 76 simplify? If I come up with the prime factorization for 76, 2 times 38, 2 times 19. So this will simplify to be 2 root 19. And then I can think about factoring a 2 out of the numerator. That will cancel with a 2 in the denominator here. And then if I were to separate those solutions, there we go.